Okay, so we're going to look at domain and range. And I'll ask you a couple things as we go along. But just to set up a start, domain is talking about like the set of numbers. I'll use this symbol as numbers for x values. Okay, and I'll show you on a graph. It'll be a lot easier to visualize when we show it graphically. And range is pretty much the same concept. It's the set of all the numbers for y values. Okay. Now, they use lots of different ways to show domain and range. Have you guys dealt with anything where they do just points? For they might give you a set. So when they talk about a set of numbers, they could do something like this. They may say that you have 3, 5, and 8 is in a set. They may say x is that, and y is 2, 4, 9. Have they given you anything as simple looking like that, or are they more using like functions on a graph where they have something that looks like this and you have to find a domain and range, or maybe both? You've done a little of both? Yep. Yeah. So those are for continuous functions. So okay, so we'll talk about the first one on the left here. That's the those are finite values. The idea is that there's just specific values. So if you're to set up your domain, something like that, they may ask you, they might show it as a set of coordinates in this sense. So I'll erase this to start. So sometimes what they'll do, and let's jump over here to decimals for this part, they might give you a table. And they might say 2, 3, and 4 are the x values, and 5, 6, and 7 are the y values, okay? So you get something like this. Can I click them all at the same time? Good, yes I can. So you'll notice here, oh, I have to change that if I go there. Give me 2 seconds. There you go. So you'll notice here, this allows me to draw. These are just really specific points. In fact, there's nothing in between them. And the idea of XER, this is X is the element of real, or it's every real number. And all that means is if you're counting, think of like counting from 1, and then you could say like 1.1 or 1.01 and 1.001. And you can continue that forever. So there's really like an infinite number of numbers we could write. So instead of writing all these numbers, we just use this. That just says, yeah, we're talking about all the numbers. That's what we're talking about. But in the specific case we're dealing with right now, get an eraser here. There's nothing in between those values. If you notice, they're just those values. So when we have a case like that, we actually just write those numbers out. So we wouldn't use XER to represent this. We would say in this case, we would say, well, the x values, and you can kind of see them on the side here, the x values are the number 2, the number 3, and the number 4. Okay, and then the y values, well, the y values in this case are very creative here, 5, 6, 7, right? So those are your x values and y values, and that's technically, this would be considered your domain, and this would be considered your range, okay? That's a simplistic way of looking at it. Sometimes, I don't know if you've seen anything like this. They do like an oval and they talk about relations. Do they talk about whether something is a function or a relation? Passing a vertical line test. Vertical line test? Okay. So a vertical line test, we're on a graph here. This one does. It passes a vertical line. You can see I draw a vertical line through these and it doesn't touch anything else. That works out great. Usually, you may get a function that looks like this. Okay, and in this case, it wouldn't pass the vertical line test because it touches 2 different points on the function. Something that's a circle runs the exact same problem. Okay, but anything that's essentially going upwards, it looks like a smiley face, a quadratic or a linear function, those are going to pass it. We won't have any problems with those. Okay, let's clear all that. They may give you an example of something like this. So disregard what I have on the side here. Maybe I'll jump back to the other page. I'll go back here. I'll show you. You may have something that'll look like this, let's say. They'll draw like an oval. And they'll give you maybe the numbers 2 and 3. And then they'll say 8, 10, and 12. Okay, and they'll say something like this. Have you ever seen this representation for domain and range? They'll call this the x values. Yeah. Okay. If it doesn't come up in your test, then obviously this is not important. But just in case it may come up, because you, like you said, it did show up in your textbook. What this is saying is we can write these as sets of coordinates. And again, a vertical line test is for visual, for like a graphical representation. So this is a coordinate, 2 and 8. So I can just kind of say, okay, that's the value of 2 and that's 8. And they may call this x, or they may call that the domain and that the range. It just depends on what terminology they use. Here, though, we have 3 and 10, and we also have 3 and 12. Okay? Now, when we look at them as just numbers, it's sometimes hard to tell. So we would try to graph something like this. I'll move the page down a little, so I'll graph it by hand, but then I'll show you on graphing calculator, which is a little nicer to look at. I have one value that's at, call that 2, and we'll say that this is the number 8 here. So here's 2 and 8, and then we have 3 and 10, and 3 and 12, right? So here's 10 and 12. This wouldn't pass a vertical line test, okay? And really the ways to know is that if an x value has more than one y value, then that would not be a function. That's not a function, okay? And we'll jump back into decimals quickly just to give you a view of that. Think of it like, let's go back, what was it? 2 and 8 I said. So we're going to change these values really quickly. 10, 3 and 12. It's a little easier to visualize here. If you take a look at that, you'll notice I'll draw a vertical line. Doesn't work, right? Though that's not the nicest line, it's not a function. All that does, the vertical line test, is tell you whether something's a function. It doesn't really technically deal with your domain and range, okay? But they're usually coupled together, so I just wanted to talk about it a little with you, just to make sure in case they it comes up on a test. So with that being said, we'll go away from this. We'll quickly take a look. I'm going to turn those off. Let's do this function. Y is equal to 2x. This is a linear function. So you might be familiar, you might remember them from like your years before in 9 and 10. This linear function, technically, I could zoom out forever. If I keep zooming out, you'll just keep noticing the line keeps growing and growing and growing. So a lot of times when we draw it on a page, we just represent it like this. We put an arrow at both ends of it, and we'll say it goes on forever. So if it goes on forever, when we go to write our domain and range, we'll say something like this. Our domain is x is the element of all real numbers, or x is in every real number, okay? And like I said before, all that means is every value from here to here, and technically these are all the x values, right? It's technically horizontal, but from every number from, we'll say that's 0 to 10, it includes them, and it's actually going to go on all the way to infinity and all the way to negative infinity, technically, okay? Now, we can put stops to that, and we'll go to another example that does that, but in this one, there's no parameters, they call it. This one's just going to go on forever, and the range of a linear function is the exact same. It's every number of all real numbers. Technically, they write this symbol like this, but I'm sure they're not requiring you to do that. That would be a linear function. Let's jump to a quadratic. And what we'll do here is a quadratic is I'll cut it off a little just so you can see. And what's neat about this program is you can use domain and range. So we'll say something like 2x squared, okay? But I'm going to give it a domain of x is less than, let's say 5. Nope, 5 is a bad example. Let's say 1. There we go. I'll zoom out a bit so you can see this. So if you notice here, I'll turn the black one off. You'll notice this quadratic, it actually stops, okay? It has a parameter here. So we can tell it's the value of 1. It's continuous, and continuous means it's just a line that keeps moving all the way down. I'll try to trace it. Oh, see, there we go. Not so handy. But because this is continuous, we're always going to start domain with that x in the element of R. So we'll say the domain is x is in every real number, okay? Now, the problem is it doesn't go, it goes this way, right? It's going to negative infinity as far as we can tell. It's going to go that way. It's not a very good infinity. But we definitely can tell it's going to stop on this side here. Let's change the color here. We have like almost like an invisible wall blocking it. Okay, so I actually have to write that in. I have to make a point of addressing that in this domain. So I put a vertical line, and usually that means like such that, and I say x is less than the value of 1. Now it might be touching 1, but you can actually tell I wrote that parameter in here so that it would visually show up that way. But this is how we would represent something like that. We'd say x is an element of all real numbers such that x is less than 1. In other words, it doesn't pass the number 1. It only goes to the left. Okay? And I can change this. Or less than and equal to 1? Yeah, I could do that too. Absolutely. Well, it does matter. It's just really hard to tell on this graphing calculator. A lot of times, or not, what your teacher will do, if they are picky about it, they'll do two different ways. They'll either represent it with a hollow 0, like in a circle that's hollow. And if it's hollow, what they're trying to indicate is it's not touching the number 1. It's only less than. If they indicate it with, and I'll draw another function just to the left here. Let me copy this over. I'm just going to move this function. Give me 2 seconds. To do y is equal to, let's say, come back here. I'm going to say -7. Oh, it's completely gone. Let me move this. 8. There we go. So you notice another one showed up there. I lost that piece. I was hoping it was going to stay. In this one here, if they represent it with a filled in circle, they're trying to say that it's actually less than and equal to. Okay? That's just symbols they use. The reason is if you look at this, it's really hard to tell. Like I can't, with my eyesight, I can't visually tell, and I can zoom in on this graphing calculator as much as I like, and it'll always look like it's almost there. So they use a large circle to kind of represent whether it's touching or not. But you're right, it could be less than and equal to. I didn't use a symbol to just represent it, that's all. Did that part make sense? Yeah? Okay, so I'm going to give us a little bit of a harder function. We're going to try this one together, and then we'll do some, we'll let you try a couple questions. I'm going to give you a function. Don't worry about how this function's made. Just worry about looking at it and seeing if we can get to domain and range, because this one's a little tricky here, okay? I'm going to say brackets x minus 5 squared plus brackets y minus 1 squared is equal to 3 squared. Oh, not there. There we go. Okay, so I've made a circle on this page. What do you think the domain will be? Start with domain. So first thing you want to ask yourself is this a continuous function, or is it like pieced together? Is there lots of little different pieces? Oh, okay, so what do we always start with if it's a continuous number? Or function, sorry. Yeah, very good. Oh my gosh, that was a terrible curly bracket. Oh, I don't know why. I'm struggling on that one. Okay, but you got it. X, ER. Good. Now, are there parameters? Does it go to the left and the right forever, this function? No, it's in between, right? I got something here and something here. So X is between these two values, we'll say. So how do I represent that? They usually call it an inequality when we have greater and less than signs. How do we represent that with an inequality? Oh, that's the point. Okay, so I'll show you a quick way to do this. Is we draw that vertical line, and we just figure out the lowest and the highest numbers. So in this case, the lowest number is 2. So I'm going to write 2, and I have the number 8. I put x in the middle, and we just got to remember, is x greater or less than 8? In this case, because it's on the right-hand side, it's less than. So think of it like this. We just always have it pointing to the left. As long as we line it up where the lowest number's on the left and the largest number's on the right, I always have it pointing down. The way this is read, so I'll put it in here so we can take a look at it, and we'll try it again after. Okay. Well, the way you can look at it is that 2 is less than and equal to x. That's true. The number 2 is technically less than the entire circle. And x is less than and equal to 8. That's right. 8 is larger than the entire circle. Okay? So with that being said, how might we do, and I'll change the color here, how might we do the range in this case? I better move that down. We're going to run out of space. So think of the range. Our domain is left and right. What might our range be? So think on whether it's continuous or not to start. So what do we start if it's continuous? How do we start this algebraic way of writing numbers? Yep, so we start with that. Because it's continuous, y is an element of the real. But are there parameters? Is there a top and a bottom to this? Okay, so what would the lowest value be, you think? Okay, good. All right, so we put such that from -2. I have the value -2 here. And then what's the highest value? 4. Okay, so we have the number 4. So we know that y is between these two. Okay, so using the same kind of method we used with our domain, how do you think we would write this? What would the next part of this be? Perfect. That's exactly right. You nailed it. That's exactly what you have to write for that question there. Oops. So